Today, Alex and I, Georg, are going to share how we are scaling data pipelines at Telekom. We will begin by looking into how we can scale using data within the enterprise and sharing the problems that we were facing in the old times. Then we move forward and discuss what are the technical foundation patterns for scaling the development process, modeling, and governance. And last but not least, we conclude concrete implementation details around Dexter at Telekom and the advantages of this asset-based approach for data orchestration. I have Alex here with me. He's a data engineer at Magenta Telekom. He's very passionate about database internals and optimizing data platform engineering. You find his contact details here. And I'm Georg, a data expert in academia and industry, solving problems with data, mostly dealing with data architecture today. How did we get started? Well, there's a lot of chaos out there. If you have ever been in Asia, you probably have seen these telecommunication cables, and it's just a mess to debug them. And data pipelines often just exactly look like this, but it's even worse there. It's immaterial, it's hard to grasp. So what is the journey of Telekom in Austria and their data? Everything started with a T, and then there was some data. In fact, people wanted to get reports out of the data and began to add more and more source systems to then get more reports. And these people realized they have to prepare and clean the data to get some more easy to use data or reusable data assets. And they figured out it's not good enough to just store it into an Access database. We need actually a proper Oracle database for this. And they figured out that using PL/SQL and some orchestration might well get their job done. And further down the line, we will see the curated data assets and everyone is happy and they can get the dashboards out of this. But this doesn't last for long. This transformation is challenged by adding more source systems, processing more data. And as you can already imagine, the chaos about what is happening inside the data pipelines is growing. Because we're using PL/SQL, it is rather hard to track the lineage, in fact, oftentimes impossible. And as a result, the quality of the data and also the time to delivery is reduced. This process is repeated again and again until we have more dashboards and even more data sources, and the chaos is growing even further. And eventually people realize we should be using some ETL tool to help us scale handling the data pipelines. You will see one ETL tool added here. In fact, later, more ETL tools will be added. And usually these ETL tools work by adding to the entropy chaos. So they're not replacing or removing, but they just add one more silo. Some people are happy because initially they get more done, but eventually the chaos repeats. So we get more dashboards out of this silo, but eventually in the case of Magenta, there was a merger and basically new lines of businesses were added, a landline model and the TV model. So obviously we get more source systems, more data, but much more data pipelines as well. And we get more ETL tools. So we get some more silos. It's not fully converged. Whatever we have converged is just converged on the surface. And we get more dashboards and people are happy. And in addition to this, big data processing systems were established just to add to this mix to process larger quantities of data. However, in reality, it led to more chaos. And in any case, a lot of data is still processed in Excel. That is the tool that business analysts and people in business really love. However, Excel is not governed. And this is obviously not ideal. So how did we get here? Well, it was time. We started on a clean slate. There just was the T and then came the data and the requests from the business, and that was growing and repeating in a vicious circle. Due to missing lineage, missing metadata, missing semantics, and a very limited collaboration model, the outcomes are high lead times and a limited data quality. The methodology and the tooling was changing, but in an agglomerative sense. It was never replacing the old data warehouse. In fact, as a fun story, we had 3 old data warehouses running, which were never fully turned off. So where do we want to be eventually? Well, we want to have proper governance and interface management established. We want to have explicit data dependencies, a unified tooling and guidelines how to collaborate easily even across departments and domains like AI and BI. And we want to break down tool silos to facilitate even better collaboration. So if you take a step back and look at the problem chart from before, where do we need to start to fix this? Well, first of all, with regards to explicit data dependencies, we have to resort to some means of data transformation that is not opaque, but actually transparent with regards to what dependencies we are creating. SQL is a really great tool for the job, and modeling SQL efficiently is easily possible with dbt or perhaps SQL mesh. In our case, we chose dbt. And unlike the SQL override box in the ETL tools like Talend or Informatica, here in dbt, SQL is and the AST of SQL is fully acknowledged as a first-class citizen. That means a lot of business analysts and ETL engineers are very happy. The next step is unifying tooling and guidelines. Well, for us, we want to work with a unified graph that connects with individual tools. We want to have a place where BI, AI, data quality testing, obviously also the data loading and transformation, play together very well in a harmonic way. It's a bit a stretch to explain it here in the chart what we want to do, but basically want to reason on an abstract level about our data and then connect various separate tools and engines into one harmonic picture. But Aleks will in a minute show you how the technical details look like. And last but not least, by connecting these tools, we want to break down the tool silos. In the past, only a very limited set of users had access to the high-priced ETL tools. Now we want to break this open and not only focus on the core data warehouse, we want to enable any business process to work easily with data. What we are providing is something like a playground with sand and toys for people in the business to join us. But it's not without guardrails. The metadata, governance, and so on are baked in. I will hand over now to Aleks to discuss about the core data platform. Yeah.
Okay, I will take over from here. Thank you, Georg. So what Georg showed us till now is how we ended up here where we are right now. But what I will now try to do, and Georg also explained what are the pillars on which we are building and what we want to do. What I will do now is I will go 2 or 3 steps back and I will try to explain the core concepts and core problems which we see and how we actually solve them. So let me start with core data platform. If I take a line and I say this is a time, from left to the right. On the very left of the graph, we will have some data source. In our case, it can be a Kafka, files, or database systems. Somewhere in the middle and over the time, we will have a data platform where we will do something with the data, and at the very end, we will present it in some reports or some operational use cases down the line. Okay, what we want to do now? We want to ingest data. So basically from the source system, we want to bring the data into the platform. We want to take those tables and transform them to another tables. So to extract some value out of the data, to transform them, to prepare it for the, I would say, upstream use cases. And what we also have to do is we have to orchestrate this process. So those 3 pieces of the process are actually the main things to do in the core data platform. How we do this? The pipeline orchestration is Daxter for us. Data transformation, we do it with dbt and Daxter. And data ingest, we do it with Spark and Daxter. We are leaving out everything else out of this picture because we want to focus first on the very core data platform. So we are leaving everything AI related, everything catalog related, and so on. If we now take a look into this process, what we are describing before on the slide before, so we can say the process is very simple. We just ingest, we transform, and orchestrate. What I was hearing in the industry is that sentence which says, I fear that what we build is very hard to push into the business units. So what does it mean? It means the process is very simple, straightforward, but the problem is that it stays, or it's very hard to scale this within the enterprise, and it's very hard to scale it within the business units and business teams, which should actually extract value out of their data. What I can say for our process is that I know that what we build is very easy to push into the business unit, and I will try to explain how we actually do this. If we take a look again into this process, we can say it's very straightforward, but what we also have to say is that we are not doing it for ourselves, but we are actually doing it for the business. And what we want to do is we want to provide to the business units possibility to extract the value out of the data and to provide better service as the enterprise, as the German Telekom and Magenta. How this would look like in a normal scenario? We would have one data team. This data team has normally a project, and we have some business unit. What would happen is that a business unit or another business unit, which also could be there, would request some implementation or some dashboard or some extraction of the value out of the data. Then data team would take their processes, whatever ingest, transformation, and orchestration is, and they will then do this in a project and provide this to the unit. But what we don't have to forget is that there are a lot of business units inside of Magenta. We have, I would say, at least more than 10 inside of Magenta. And this is something where one team can't scale to do all the job for all the business units which are there. So what we can say is that it's very hard to scale across the company. What would then happen is that people will say, okay, we have to scale, we have to multiply the teams, then we will get another data team. This another data team will have a next project maybe, or both teams will have one project, but it's very hard to scale for more than, I would say, 10, 11, 12 people. Or if you don't scale and we have two different teams, then the tooling and process can start to diverge. What we actually want to do is we want to push those projects to the business units, and we want to give them the possibility to scale this process and that they do it alone. But we will now discuss how we achieve this. So we can give this to one unit or to another unit. The first thing what we did is we divided the people into the develop framework people and use framework people. So what does it mean? We introduce something what is called data platform team. Our data platform team is doing or providing the template project, which has frameworks inside of this, which are actually then or the projects of the data team or sales units are instances of this template project. And what we also as a data team provide is the infrastructure. What is very important to say here is that thinking in a building block structure is important, because just this way you can take this one building block and you can multiply it. How we do this? We introduce modern tooling like dbt, Daxter, Pixie Docker. And what we also do is we introduce the new processes for development. We introduce modeling tool and metadata around the data platform. Now we know we have a data platform team, but what is really important to say is that having a data platform team doesn't mean that your platform scales. The first thing is building block with governance, modeling, and software engineering principles. The second is understanding data platform vendor war. We will tackle this in a moment. And the third one is understanding tool silos. This is also a very interesting one. We will also tackle it in a moment. What does it mean, break the silos with building block? You remember that the platform team is providing the infrastructure. And if I now take a look into a modeling tool, which we have, we can say, okay, this is every and each model which I have inside of my platform. What I can do with this model is actually provide just one piece of this whole process what we were saying earlier. So ingesting, transforming, and orchestrating. And this would work. Yeah? But the question now is, does this scale? What our data team provides is a template project. And this template project contains all the pieces for this ingest, transformation, and orchestration. And what then we do, or business units do, is that they're taking this project and multiplying it within our infrastructure. And every project is actually building a small piece or small part of this model. And now you can imagine that if a model grows, then a new piece of code is added, or a new project, which is actually implementing this model. You can imagine now how this grows. I can have 5 projects, and those 5 projects can be also parts of this model. When this is actually very powerful is when you start to combine them. So this is also very important, that you are able to combine the pieces between 2-3 different projects. What are all those projects here for? Is, for example, to create the report at the very end. But what we also want to do is we want to provide this possibility to business unit, that also if a business unit comes and say, okay, we have people who know how to do with the data and are willing to do this, then we can say, here is the playground, here is the building block which you can reuse. We use it for a long time now. It works for us. You can then create two new projects and do whatever you want there in order to create your dashboards. Just having multiple projects is bringing some challenges with it. We have to have a dedicated team maintaining the infrastructure and template project. And also the governance and modeling tools are very important to support this project so basically multi-project setup. And what does it mean? Modeling and governance is that if I imagine that I have my infrastructure and I have multiple projects which are somehow connected to get to the report at the very end, and if I say how I as a developer or I as a business unit can make sense out of this whole platform, is actually divided in 2 phases, I like to say. So the first phase is development phase, where I have a modeling tool. Inside of this modeling tool, I can define and create everything what we want to achieve with our projects in order to get some value out of the data. And then we will implement this into the project. And the second phase is actually exploration phase. I develop, I implement, but now when I implement it, after this, I want to push it somehow back and provide it in some sort of the data catalog, which I can then use for exploring and understanding what assets are there, what can I do with those assets. And then, of course, I would go into the development phase and then do this round again. The second point which I wanted to tackle is the understanding data platform vendor war. What does it mean now? If we take a look into the data landscape, we will say, okay, there are a lot of them. And it is really increasing with amazing speed how new, I would say, startups and companies are arising. And what we can say here is that we have to think about a way how to resonate about the state, what the data engineering world currently have, and what we want to achieve, or how vendors are actually moving pieces around to understand what we want to build. How I like to separate them is to say, what is my core piece of my platform? So every company should start from some piece of the code. And I would say some companies start from the execution engine, some companies from the SQL transformation framework, and some from the orchestration engine. What does it mean? If I start on the beginning, I can say, okay, there are potentially two cloud vendors, Google Cloud and Azure, and they started their journey with some engine. There is a BigQuery and there is a Microsoft Fabric. Which engines are also there? For example, Databricks or Snowflake. Those are also engines. So we can build our platform around those database engines. If we take a look into the Databricks, then we can say, okay, it runs on every cloud. And if you take a look into Snowflake, it's the same. Now we can ask ourselves how development environment looks for those platforms, or for those data platforms, so to say, is that Jupyter Notebook you can use in Azure. In the Databricks you can use also something like Jupyter Notebook. You can also write some types of the packages which you can then deploy and then do some workflows in the Databricks, and you can do something similar in the Snowflake. In the BigQuery, now they are doing some improvements, but it's the most useful thing in the BigQuery is actually the UI. If we ask ourselves what is the orchestrator, we have a composer. In the Google Cloud, we have Data Factory. In Databricks, there are some workflows. And in the Snowflake, there is also some proprietary workflow engine. And now we can ask ourselves, okay, what is plus and what is minus? If we say full stack is offered by one vendor, so the interchange between the Google Cloud and Azure is very hard. Interchange between the Databricks and Snowflake is very hard. Now it's much simpler with the Lakehouse approach and so on, but it's very hard. And normally you are in end-to-end integration lock-in. We can also say that deployment is almost always a workaround, and there is no software engineering support. So there is no local development. Everything should happen in some notebook, in some web UI, and orchestrations are always second-class citizen, and they're almost always task-based, which Georg will say later more about what does it mean to be task-based and asset-based. There are also very good things is like big companies are behind those platforms. They are normally frontiers in the Lakehouse approach, and notebooks environment are very convenient. I don't know if for deployment, for development, not so much, but I mean, from exploration perspective, very much, but from the software engineering side, not so much. And what is also good is that everything is in one place and you have one vendor behind all the toolings which are integrating with each other inside of this vertical stack very well. If we take a look now into the next, SQL transformation as a core of the data platform, we can say because on execution engine platforms, the development was not so good and not so software engineerish, there was a place for DBT to jump in and say, okay, we will take this piece of cake and implement or build around the software engineering there, which was a really great improvement for the data engineering world. And what you can imagine about DBT is that they have some proprietary cloud and they don't have engine, but they actually use all the other engines which are supporting DBT which are some of them are really well supported. If you now ask yourself, okay, what is minus and plus? DBT is just orchestration for the DVH part, so it doesn't have orchestration for another parts of the platform, and it's actually frontier in some SQL development and software engineering around DVH development. What we also have there as a new concepts are SQL Mesh, which are kind of newer generation, which are building around more understanding of what behind the SQL happens, and to understand how the SQL statements are connected. But it's something similar. SQL transformation is the core of this platform. The third approach is the orchestration engine approach, where the orchestration engine is the core of the data platform, and this means, for example, that Daxter is falling into this group, and Georg will say more about Daxter later. They're also providing cloud hosting, and you can imagine then that engine which you're using is not so much important, and they have a very great integration with DBT, but actually doesn't matter which SQL transformation you are using. What is bad about building around the orchestration engine is you need a bit of more technical knowledge to set up and use correctly the data platform around the orchestration engine. But what you get for this is that integration is important in the Daxter. So if this is DBT or SQL Mesh, it doesn't matter so much, because eventually if the SQL transformation framework is good and it's used, then it will eventually land into the Daxter as an integration, and you get also the full software engineering and local development opportunities. There are also some other, like Mage. It's for us not so much important. We will speak more about Daxter, but just it's important to say there are also other vendors which you can think of as the orchestration engine first. Yeah? If we now say from Magenta side, what we have from the Magenta side is we have Daxter as the orchestrator. We are using Daxter Plus as a hosting solution. We also use DBT, and we are using BigQuery and Google Cloud for transformation. The last point which I wanted to speak today about is the understanding tool silos, and what does it mean from the perspective of the data engineering process. So again, the same very straightforward process, ingest, transformation, and orchestration from the source system to the downstream application. And if now a developer would ask himself, okay, what should I do to get one end-to-end report use case done? How this would look like right now in some other solution? You will have some source system and you will start to ingest. What does it mean now, ingest? Is you will go to a tool which is just for ingest. For example, NiFi, for example, Data Factory, Airbyte, or potentially somehow script-driven Spark. Yeah? And what this will do for you is it will take the data from the source and it will bring it into the platform. These tools would then bring the data inside of the data warehouse or some storage object store. And then what you would have to do for the transformation part is you will have then to write some DBT transformations or some notebooks or some Spark scripts. And then for the orchestration, you would have to go to the Airflow and say to the Airflow, okay, now you run for me a notebook or you run this Python script. You would also do in some other orchestration, but they are kind of separated. I do DBT, then I go to the Airflow and I implement this piece of task which should be done for me for this transformation. On the very end, you will then go to the to some dashboard provider, and you will say, you will create the dashboard, and then you will have to make inside of the provider the schedule for the refresh, how to bring data and when to bring data inside of the dashboard itself. How this looks like in our case, we have a project, and inside of this project, as the core of the project is Daxter. And for the first part of the ingest, we have configuration, we call it an ingest configuration file, which are then transformed in some Daxter assets, which are bringing data inside of our platform. For the second part of the transformation, we use dbt, which is again integrated inside of the Daxter, and Georg will say more about this later. And the last part around the reporting is also integrated inside of this project, again also as the integration on top of the Daxter. So you can now imagine that if you look how this looks right now in some different use cases, you would have toolings where you have to go for the ingest, and then you will have some transformation tooling where you will go for the transformation, then you will go for the orchestration in some other tool, and then for reporting in another tool. If you would take a look into our projects, you would see it, all the pieces from the very left source system to the very right reporting integration, you will see them sitting on top of the Daxter as the core of the project, and they will be actually unified, and you would not have tooling silos around and having to go from tool to tool to manage the states and implementation between them. This was the last topic from my side. I will now hand over to Georg, that he speaks more about Daxter and why we as Magenta decided to go with Daxter, and what are the main and core concepts.
Yeah, I'm back. Thank you, Alex, for the technical deep dive. Sometimes things look crazy, but when you look closer and learn more, it turns out they're just complex. And I will now share how we master the complexity of data at Magenta. We have chosen as Magenta in Austria to work with a graph in the data platform, where every state or node is in the graph is something we care about, and we have a transformation as a connection between these states. We are using Daxter, as Alex mentioned, to implement that graph for us. So we have decided to build around the orchestrator as the heart of the data pipelines, and not around a single execution engine. Why is this so crucial? Imagine a couple of years ago, everything related to data was stored in Oracle. And Oracle already was facing a huge issue by itself. It had a hard time loading the data into the database. Once it was there, people were happy. But then, at a later stage, AI arrived, and again, Oracle faced a problem. But this time, there was basically no help besides pulling the data out, doing the data science, and maybe storing results back to the database. When building around the orchestrator, we can smoothly handle any data transformation tool, and this means we can bridge also AI and BI workloads easily. This means we are more future-proof. How is Daxter deployed? So Daxter itself offers the open source deployment where various workloads are running on function as a service providers, and basically the enterprise deployment where you are using either a hybrid deployment or a SaaS deployment. We are using the hybrid deployment here because it is basically more secure and our data is safe. So that means it doesn't leave our premises. We are introducing software engineering best practices for project development and for project deployment. That means mainly we can focus on building reusable artifacts of codes. Instead of copy-pasting SQL everywhere, we can create testable modules, test these, and use them in the places where they fit. And we can build automation. We in fact build automation everywhere. CI/CD pipelines make sure that only high-quality code goes into production. But we have more automation when the pipelines run around data quality testing and the collection of metadata. And then there's the asset-based mindset for data flows. It's something like as if we had created a calculator for data dependencies. Just like a calculator that is good at crunching numbers, having the calculator for data dependencies, that is Dexter in our case, makes the computer or the data dependencies actually a friend instead of an enemy that we have to fight against. Now, these dependencies can help us deliver high quality data faster. By adopting these principles, we get several new concepts in orchestration, and I will briefly touch about them in a minute. They are really useful to scale working with data to even more people. Some of the new concepts are, first of all, the asset graph. I would consider this actually operational lineage, so it's not like a traditional data catalog where you can just view the data. Here you can really literally work with the data. So in case of a backfill, you can literally trigger the specific operational application or task or backfill operation just from the user interface. Then there's a metadata-driven pipeline creation that allows us to pull in external metadata and then create the pipeline from this metadata. And last but not least, reusable components for handling tricky things like I/O. Here at the bottom, you can see how an example data pipeline goes from start to dashboard. In fact, from data in the source system that is pulled into the platform via the ingestion mechanism that Aleks has talked about, then transformed with dbt, with SQL, into a data vault, from a raw vault to a business vault. Actually, we're skipping this here a little bit to keep it a bit more concise, for example. And last but not least, push the data over into the visualization tool. And what you can see is individual dashboards are directly connected to the upstream or to the left side data assets that are filling them with data. And why is this crucial? In the past times, the Tableau was refreshed, or the BI tool was refreshed, usually once a day or based on a specific cron string. And the accompanying data was sometimes stale or sometimes not delivered with high quality. And this gives us a couple of advantages. First of all, we have this observability. Secondly, we can trigger Tableau as quickly as possible, so we can actually deliver data faster. We can trigger it only when needed and not just on a cron, on a specific cadence, so we can even conserve resources. And last but not least, we can make sure whenever we are triggering it, that the upstream data quality checks are green and the quality is high. So we can make sure that the business user never sees weird or ill-shaped data. One example, what does this asset graph actually mean? Let's make this complex sounding concept easier to understand. Here, let's bake some chocolate cookies as an example for how orchestration can work. Let's take the ingredients and bake the chocolate cookies. And obviously we need eggs, we need flour, and in the end we want to see the chocolate cookies. And let's split this down into tasks and states, because we perform specific steps in the recipe and then we have some output. Actually, we have some input as well, or needed. That's the eggs and the flour. So let's combine this. That's the task. And the output of this is the cookie dough. And we need to process the cookie dough further and need to add chocolate. So we combine it further with chocolate. And the output of this is a chocolate cookie dough. Obviously, it's not yet the finished cookie. We need to bake this in the oven, but then we have the cookies. And this is really interesting, because if you look at this, we see that the blue colored boxes represent the tasks. And this is what normal orchestration solutions like, for example, Airflow commonly represent. On the opposite side, or adjacent side, I probably should better say, we see the states of the magenta colored boxes. And that is the things that we actually care about. And wouldn't it be neat if the data orchestration solution would be literally caring about the things that you and I and the business is caring about? This is what the asset graph is about. So we are connecting here the states that we care about with the transformations to go from one state to the next one. But what are the implications of doing this? Let's step back and again look at the ingredients and the chocolate cookies. We have two ways to get there. One way is the task-based approach. So we see combine, add chocolate, and bake in oven. it's already clear that a lot of stuff that we have seen before, the state that we care about, is not transparent for the computer, for the data dependencies, and thus the computer cannot act as a calculator and help us solve the data challenges. But if we look at the state that we care about, that you and I care about, and that the business cares about, we see something that is looking like a data flow graph, something that is rather easy to reason about. And in fact, this graphic structure holds all the pieces that the computer can reason about your data as well. And this is really, really powerful. So we have the task-based orchestrator and the asset-based orchestration process. What are the advantages of asset-based orchestration? Well, let's look as a first example into testing. How would you usually run a testing procedure in the task-based way? Usually, you would probably run a process that is outside of the traditional inline data pipeline. That might be a separate data observability tool or some handcrafted tests. The problem is you will very easily mix high quality data with low quality data and run into data quality issues. And it's really, really hard to make sure that your tests and the pipeline are in sync. Here with the graph, it is super easy. We can add additional data quality testing steps to the individual nodes in the graph just as needed. And we can make sure that the computation along this graph only progresses further if the tests are green. Or perhaps we can actually let it progress further if the tests are yellow and emit a warning, but the business will be alerted and will know they have to do something. The next point is freshness. Again, in the traditional way of implementing this, it is really tricky. First of all, you have to somehow keep track of the state. Is it fresh or not in some external place and then reason about this? And that can be hard. And secondly, you have to trigger all the operations all the time. And then inside each operation, figure out, is this now something that I want to execute or not? In fact, that means usually a lot of manual complexity. When working with an asset-based system instead, you can ask the individual asset or the node in the graph that you care about, that I care about, and also the business cares about. Like, are you stale? When should you be actually executing? Do you want to be refreshed? And then we can trigger the refresh as needed. And last but not least, it allows to perform new types of scheduling. In the past, so that means in the task-based orchestration scheme, we had to schedule based on explicit jobs. Now imagine your team has a job and the other team has a job, and you somehow want to make sure they are operating together. It's just a mess. When do you create a super job? How do you connect them? It is really, really hard to make data scale in the traditional job-based way and coordinating the refreshes of jobs as needed and in the right order. However, here with the graph, the computer fully automatically can take care of this with declarative scheduling approaches. Let's take a step back to what we have seen already. Let's look at the boxes again. Can you now understand this asset graph better after you understand the cookie analogy about bringing data in, transforming it, testing, continuing in the transformation if the tests are okay, and then visualizing it, perhaps even adding certain AI steps directly into the transformation graph as needed? How can you scale this asset graph to many people? That's a really interesting question. And it means various personas have to collaborate with the individual strengths. And what you have to do as a platform team operating the platform or the playground, like I like to call it, is you have to make sure the right metadata is available to facilitate the collaboration. In fact, this means you must ensure that machine readable metadata can be collected. And if you collect the right metadata, the largest part of such an asset graph that you can see here, in our case, the sample project with more than 500 nodes, so that means machine learning models and tables and views, can be generated fully automatically from what people have collected. How does this collection procedure look like? Well, in general, we have this collect metadata function, and based on the metadata we have collected, we then map it to this abstract graph in Dexter and create the boxes that we care about, and we construct the graph. But let's look at some more tangible examples. Ingesting data into the data platform is something that should be declarative and well-defined. In our case, we have a custom ingestion framework, and we collect the configuration of which source to read from, how to read from it incremental or full load, or what data to transfer. That is all defined in the declarative YAML-based configuration. And we can reuse this and bring it into the asset graph by iterating over the individual configuration items and creating the ingestion assets. In our case, as Alex said before, we're using Spark, so we can then imagine that we would run some Spark read with the config of the source and then write it according to the configuration. Well, dbt already provides a nice lineage graph to work with from the start. So what we are doing is we are loading the machine readable configuration from dbt, and from that graph dependencies construct the asset graph in Dexter. So we make now Dexter aware about what people and data analysts and BI engineers and analytics engineers have already curated, and feed this over into the platform, into Dexter. But we don't need to redefine the graph. We can use what is already provided. Interestingly, certain people at Telekom asked us, how can we run arbitrary SQL that is provided by end users? For us, this is a really easy answer. People just add it into the mix, meaning add it into the dbt projects as they see fit. The CI/CD pipeline will kick in, and the rest is history in the sense of fully automatic, fully tested, and part of this asset graph. In fact, we have curated and created the Tableau fine-grained integration into this asset graph. And all you have to do is you have to construct the dashboards on the Tableau server. The rest is taken care of fully automatically, in the sense of we connect to the REST API of the Tableau server or Tableau cloud endpoint, retrieve the metadata, and then again link it to the asset graph. And we literally link it in the sense of connect the source tables in your data warehouse with the visualization as you have seen before. So it's one homogeneous graph. Reusable components sound so simple. With an IT background, we are used to creating libraries, talking about dependency injection and so on. But first of all, what does this enable? Why would we want to do it in the case of data? And how can it really work to bring it down to earth so people can use it easily? Well, we must create functions that we define once, test, and then we reuse the tested functions in multiple places. In the case of Dexter, we have a possibility to define resources and I/O managers. Let's imagine you want to curate data and collect it from your CRM system, let's say Salesforce or something else, and you want to download it and then push it later to your data platform, transform it, machine learn it, and then push it back to your CRM system. Well, as you can imagine, there's a lot of data flowing back and forth between these REST APIs. But if you want to bring this data pipeline down to the size of a single developer's laptop, you have to mock it and add the right replacement resources. By thinking in resources and in replacement resources, you can make complex things simple so people can reason about it more easily or don't stress your systems and where you don't have to pay for certain API requests. I/O managers are simple. I/O managers are similar in the sense of they can harmonize and simplify complex I/O operations. Imagine you have a data frame, let's say a pandas data frame, and you want to store it. Well, if you want to store it over time, you have to think about partitions. This is tricky, and this is something that some analysts don't want to worry about. But if you are the platform team, you can code this functionality once, how you want to handle your batch ID, your partitions, and simply feed this as a reusable function. And now what we can see here in this little example is let's call it awesome machine learning model that takes some input and is computing something. And the interesting piece about it is the dependency injection mechanism, because we now have this defined I/O manager and reusable resources. Because we do have now the resources and the I/O manager, we can reuse them here. As you can see, in the function signature, we get a pandas data frame and the BigQuery resource. But as an analyst, who is just a junior analyst, or maybe someone from the business who learned Python yesterday and a bit of OpenAI vibe coding, I can already be productive on day one, because I can simply say, give me this particular data asset that I care about, And then you can actually continue your way from where you want to start. You can simply focus on the business logic. There's no need to focus about the tricky details that in the end make the platform run and scale to many data assets. Because this is totally abstracted and handled by the platform team, by the asset graph, and by the reusable components. By doing this, you increase, first of all, this day one productivity by scaling the data pipeline down, by making it easier and accessible to more employees, and data scientists don't want to focus on the complex I/O or engineering topics. You make your data scale to many more people and you can get more done. A couple of takeaways which are quite important. We have an integrated asset graph here, and this is key to make sure that ingestion, transformation, reporting, testing, and even AI are part of this graph. This makes communication and collaboration so much easier. In fact, we have event-based connections. So if there's one department that is offering reference data, let's say addresses, another department consuming this, let's say marketing, and wants to send out some offers to customers. In the past, people were waiting a long time and sometimes working with stale or bad quality data. But now, due to an event-driven connection, basically as soon as the upstream data is refreshed, the downstream one can be updated just as well. We can also wait if we want to wait to save, let's say, the credit card that is powering our cloud bill, but we know that the data is stale and that we have to refresh it to have the right state synced consistently across the stack. This allows for better collaboration due to the asset graph, as the tool silos are reduced and we have this abstract layer that is connecting everything. But not only this scales to many people, in fact, these reusable resources allow us to scale even further by encapsulating on the right level to make complex things simple. And we have software engineering principles baked into the core of the platform to enable the self-service that the business, the analysts, the data scientists need. We offer the blueprint. We automate all the things with CI/CD, including stateful and stateless checks and data quality checks inside of the pipelines. We offer this don't repeat yourself or dry principle. So we build components once and then share them so that many people can benefit from this, as discussed before, via the dependency injection mechanism. And we make the business departments a key part of the process and the pipelines. Don't push them away. We work with metadata a lot, and we are collecting executable specifications of the metadata and data contracts to, in the end, generate and automate as much as we can, in particular around interface management, preserving the semantics, and also compliance. We have to make sure that the right security classifications, PII labels, and so on are collected, so the data can be treated as it should be, or deleted in the case of retention. A couple of last things that I want to mention. First of all, you can join us. We have open sourced the key principles of what were presented here in a project on GitHub. It's named Local Data Stack. And it's not as, let's say, fully fledged and enterprisey as we presented here, but it's certainly worthwhile to explore. And we have added the Tableau integration for the fine-grained connection to the dashboards. I want to thank the whole team. It is a lot of work and it would not be possible alone. I'm very excited for the journey ahead, and also want to thank Aleks for presenting today here with me.